Hey, what's up? It's me, Miss Wesley. Today we expand upon our trig knowledge starting on Trig Packet page 14. I see the heading at the top says trig functions of non-acute angles. I mean, we've taken trig functions of non-acute angles before. All the quadrantals we actually know by heart, right? The sine of 180, we know that's 0. The sine of 270, we know that's -1. But we've been focusing more recently on acute special angles like the sine, cosine, and tangent of 30, 45, and 60. Speaking of 60, check out this form up. So it says, can you sketch the angles, drop a perpendicular, and make a right triangle out of these four pictures? So if I sketched just my best idea of a 60-degree angle, I've got standard position, you're going to be in quadrant 1, initial sides on the positive x-axis, and I'll just draw a little right triangle from here. I'll drop a perpendicular down, always connecting to the x-axis, not the y, and there's your 60-degree angle. Okay. 120. Does that have anything to do with 60 degrees? Well, let's see. You've got your initial side here. You've got your terminal side over in quadrant 2. And when you drop the perpendicular, here's your 120-degree angle. But isn't this little angle in here, I'll call it theta, isn't that 60, right? We've just drawn a triangle that's about the same size, just in a different quadrant. I'll squeeze a theta in there too. How about 240? Does 240 have anything to do with 60 degrees? Well, it absolutely does. You've got your initial side, positive x-axis, terminal side down in quadrant 3, and what do you know? Remember, we're always using the x-axis to make this right triangle. If you've gone all the way 240 degrees, that's exactly the same amount, 60 degrees past 180. So you kind of have a triangle of about the same size in quadrant 3. And then predictably, quadrant 4, here's a 300-degree angle. Here's your right triangle. If you've gone 300 degrees, but you haven't made it the whole way, you've left out exactly 60 degrees until you're back to the 360 the whole way around. So each of these angles, yes, you're in 4 different quadrants, but they have a special link, a special connection. They each have what's called a reference angle of 60 degrees. Reference angles are going to be important to us because you might get bored with your exact values of sticking in quadrant 1. You want to break out. You want to get to all the other 3 quadrants. So values of trig functions of non-quadrantal angles greater than 90 can be determined from their values at corresponding reference angles. Let theta be an angle, let's define this, in standard position. We'll say its reference angle. If theta is the original, let's just write the reference angle as maybe theta prime, like that. It is the acute angle, that's important, made by the terminal side of your original angle and the x-axis. So it's kind of silly to talk about a reference angle in quadrant 1 because you'll see at the very bottom of the page in quadrant 1, if your original angle theta lies here, it's the exact same as your reference angle. That's the acute angle made by the terminal side and the x-axis. In quadrant 2, however, right, you haven't made it quite all the way to 180, you're coming back this theta prime. Theta prime's just going to hug the x-axis and be that acute angle. Here's a quadrant 3 example. You're all the way down here. Here's your theta prime, acute angle, hugging the x-axis, just this little portion in here. Quadrant 4 works as well. You're coming all the way almost to 360, but not quite. Well, you're leaving out that reference angle is going to be theta prime. So we could, and this diagram is really cool too because it helps you figure out the calculation in each quadrant, but let's take a look at these examples. Can we draw an angle of 142 degrees? So really we just need initial side on the positive x-axis and terminal side in the correct quadrant. We shouldn't be in quadrant 3 yet, right? We'll be in quadrant 2, and I'll draw it like that. This is 142 degrees. And the original question posed was, what is the reference angle, theta prime? Well, you're always using some sort of x-axis calculation here. And the x-axis, I'll just draw the degree measure here. You went from 0, not all the way to 180, not quite. You're coming back a certain amount. So for a quadrant 2 angle, we can always calculate the reference angle using 180 minus that original angle. So 180 minus 142, and we'll put our answer in degrees. 38 degrees is going to be the reference angle in this particular picture. So there's quadrant 2. Where's 300? Well, 300 we were actually just looking at, right? We drew a 300-degree angle in the warm-up. Here's initial side, terminal sides in quadrant 4. And we mentioned, you remember it? You're going 300 degrees. You haven't made it here. Now we're not really focused on 180 anymore, and we're really always ignoring the y-axis. We need 360. You haven't come all the way 360 for quadrant, I'll put this here, quadrant 4. Use our Roman numerals. You want to get theta prime. We'll do 360 degrees minus how far you came, 300 degrees, to get back to that 60-degree reference angle. That's a big one because we would know the sine, cosine, and tangent of that angle. How about negative 135 degrees? Let's practice drawing a negative angle now too. Well, you can always start standard position, positive x-axis. Let's go clockwise instead of counterclockwise because of that negative angle measure. And we're coming 135 degrees. So we're going 135 degrees clockwise. Whereas the reference angle in quadrant 3, it always hugs the x-axis. So I'll put a theta prime in here and see if the picture helps. Well, here you're focused on the 180. 180, I'm gonna say minus, I know this is negative, but this is 135 degrees worth of distance. So minus 135 can give you a 45-degree reference angle, which is good news too. What I'm trying to claim, and as we move forward with the lesson, is if you know about the trig functions of this, you automatically know about the trig functions of that. And come back to this diagram when you need it. And I'll emphasize again another time, we never really talk about using the other quadrantal angles. In none of these calculations do we use 90 or 270. It's as if we're completely ignoring the y-axis. For quadrants 2 and 3, you can use 180 degrees to get your reference angle. And for quadrants 1 and 4, you're more on that 360-degree marker. Okay, so now let's see how we can relate this to some exact values that we're familiar with. The exciting part about this lesson is we can now find trig function values of all angles with reference angles of 30, 45, or 60 exact value, no matter which quadrant they fall in. And you have a nice picture here for 210 degrees. I actually didn't have to give you this picture. We could have figured out the reference angle on our own. Just make sure you agree with what you see here. If you're coming 210 degrees, that'll take you into quadrant 3, and you're 30 degrees past 180. This is the magic number. This is the reference angle. I'll just put a theta prime there that we'll be using for this problem. So let's just start with sine, cosine, tangent. I'm going to use all this space. So sine of 210. The rule is it equals numerically the sine of its reference angle. But I'm going to leave a little space before I write it. The sine of 30. That's its reference angle. But it might not necessarily equal the positive sine of 30. It might have the opposite SIGN. It might be the negative sine of 30. How do we decide? Well, we got to think back. How do we decide what sine our trig function value as a solution is going to be? One good acronym for us was this. I'll put it up at the top. ASTC, right? All students take classes. All students take cookies. All students take calculus. It tells you which trig functions are positive in which quadrants. They're all positive here. Only sine and cosecant are positive in quadrant 2, and in the T quadrant, I'll put a big T here, only tangent and cotangent are the positive trig function values of the 6. So since we are in a quadrant where only tangent's positive, sine of 210 isn't going to equal exactly the sine of 30, it's going to equal the negative sine of 30, and that comes from ASTC. Now we got to think. In a second, we'll fill that table out again to help us out, but think of the sine of 30 degrees. Sine of 30 degrees is going to be 1/2 if we think of it. And actually, maybe I will fill it into the table just for reference. Remember those patterns? Why not? We knew these were all over 2, right? And these first 2 rows were the big ones to fill out. When we need tangent, we'll fill that in too. The sine counts up, and we'll talk more about this in the coming days. So 1/2 for sine of 30, square root of 2 over 2 for sine of 45, and exact value, square root of 3 over 2 for sine of 60. And the cosines are going to do the opposite. Start at the square root of 3, then go down to the square root of 2. 45 is that nice anchor point, has the same sine and cosine, and then just a 1/2. So sine of 30 is going to be 1/2. Let's make this answer negative 1/2 because we're in quadrant 3 now. How about the cosine of 210? Okay, it'll equal the cosine of its reference angle. Will it be negative? It absolutely will because we're in a quadrant where only tangent and cotangent are positive. So we'll make it negative square root of 3 over 2. Okay, tangent now. Tangent of 210. It'll equal the tangent of 30 Will it be negative? I've got to ask you that question. I've asked you on all the others. Well, here we're going to keep this positive. I'll even write a plus sign there just to emphasize, because we are in a quadrant where tangent stays positive. So tangent of 30, my best way a lot of times is to put the sine over the cosine. So this function over that function, that's your quotient identity. Those 2's will cancel. You get 1 over square root of 3, or rationalized. This is going to be our answer, square root of 3 over 3. And that should do the trick. I did neglect the reciprocals. Might as well put them in there too. So cosecant of 210. I'm not even going to write that it's the negative cosecant of 30. Instead, I'll just flip this solution. So negative 2. Secant of 210. We have to take the reciprocal of this answer. So negative 2 square root of 3 over 3. And what's the last one? Cotangent of 210. Should just be the reciprocal of this, and we'll get the positive, because we're in a quadrant where it's positive, square root of 3. Pretty cool. And that's just one angle. That's 210. Over the coming days, we're going to talk more about reference angles and which exact values we can find in each quadrant. So there's a good little mini set of steps here, and we'll try the first couple of these, evaluating trig functions of any non-quadrantal angle theta. First, find the reference angle. That's a great step 1. Then use ASTC, depending on the quadrant in which theta lies, right? We can affix the appropriate sign to the function value. So we'll use both of these steps. All right, check out all these numbers. Yikes. Okay, let's just take this one step at a time. We'll look at number 10. We want the sine of 330. So step 1, we need the reference angle. I'm going to do this off to the side. Think of a quadrant where you're going to put 330. So you start, positive x-axis, 330s all the way in quadrant 4. It's actually almost all the way around to 360, but not quite. I need that, if this is 330, I need that reference angle, that theta prime. And we can use 360 minus 330 to get 30 degrees. So it looks like we're dealing with 30 degrees again, just like the last one, but we're in a quadrant 4 where we're ASTC. We got to keep that in mind. We're in a quadrant for this problem where only cosine and its reciprocal get to stay positive. All others come out negative. So here's how I write it. Sine of 330 equals the sine of its reference angle, that acute angle between the terminal side and the x-axis. But since we're in a C quadrant where only cosine and its reciprocal are positive, we'll keep this answer negative. If you need to, glance up to the table. Maybe you're just getting so used to the sine of 30 now that you remember that it's going to be a half. Negative 1/2 is your exact value. We didn't reach to a calculator, and we came up with an answer for a quadrant 4 angle. Okay, yikes, 210. Man, we're seeing a lot of, I bet you this one's going to have something to do with 30 as well. Let's find out. Can we first get a reference angle? So negative 210. Start at 0, right? Initial side. You're going to travel clockwise 210 degrees. So that's past 180. 210 this way. We'll say negative. Move that down. 210. What would our reference angle be? Well, how much further than 180 did we go? If I take 210 minus 180, I just want to figure out how much further we went. We went, what do you know, 30 degrees, a little bit too far. So your theta prime is going to be 30 degrees. And then just because it's a good idea, think about the sign of your answer. AS, we're in a quadrant where only sine and cosecant are positive. So let's say tangent of negative 210 is going to equal negative, because we're in quadrant 2, the tangent of, let's say, its reference angle. Regular old 30 degrees is kind of what we've been using lately. Well, negative tangent of 30 degrees, if I think about the tangent of 30, that's going to be square root of 3 over 3 when rationalized, and negative because we're in quadrant 2. Number 12, as soon as I see cosecant of a value that's above 360, I'm going to find something coterminal that's lower than 495 by subtracting 360 from this value. So let's find the cosecant of 495 minus 360, which is 135. Now we can start the problem. We notice 135 is in quadrant 2, right? AS. You're going 135 degrees this way, meaning your reference angle is 180 minus 135. We can use theta prime equals 45 degrees here. So no need to put a negative sign. We're in quadrant 2 where sine and cosecant are positive. It's going to equal the positive CSC of 45 degrees. We are flipping the sine of 45. We're flipping square root of 2 over 2. And this one should just come out to be the square root of 2. That's the start of our practice, but we'll get some more time to go over this in the coming days. Have a nice day. I'll talk to you soon.